All right, hey, welcome back. So now I'm gonna go over the second question in this worksheet, which is a runtime analysis in terms of real code. So if you look at this, the question asks us to specify the runtime in big O, big theta, or big omega notation. And you want to give us the tightest bound possible. So just as a quick recap, a big O is the upper bound. And a big theta is a tight bound. All right. And a big omega is the lower bound. All right. So, and just one more thing, that a big theta is only defined when big O and big omega coincide with each other, which means they have the same runtime term for big O and big omega. And we're going to see an example just in a bit. So before that, remember we want to, when we do a runtime analysis, we want to specify a input size. And in our case, since we are input an integer n in all of these three functions, so we're going to assume our input size is just the value of n, so like an integer value. Right? So let's look at the first question. So the first question is we take an input n, which is the value n, and then we have two for loops. The first for loop is iterating through n through I equals to 0 equals to. The first for loop is iterating through from I equals to 0 to I is less than n. And the second one is j from 0 to n. All right? So by this, we know that for the first loop, we're going to run it n times. All right? Since I will be increased one by one until it gets to n minus 1, that is n time. And similarly, the second loop will get run n times. So how many loops in total? So the number of tasks we are doing, or a better way to do it is the number of time that we reach this line, all right, will be n times n, or n squared, all right? Because for every round of the loop, we're going to run that linear n in this double for loop, and we're going to run it n squared times. All right? And then we're going to assess that how much time it takes us to do this linear n. And it says in the comment that it's run in linear time with respect to the input. And the input here is n. So the time per task is equals to n. All right? So that's given us in the comment. And therefore, the total runtime going to be n squared, which is the number of times we do the task, times n, which is the time cost of this task, which is n to the cube. And now, since, as we said, we can never assume that n is really small to reach a best case, so all we want to do is we want to see what happens when n goes to infinity, or when n is large enough. So in this case, there is no worst case or best case, because no matter how, you need to run all n squared times of this double for loop, and in each for loop, you're going to run a linear time function. So that being said, we will have this function that the upper bound is n cubed, and the lower bound is n cubed as well. Therefore, the lower bound and the upper bound coincide with each other, so we can use a tight bound, which is theta n cubed. And that's the answer to this question.